Okay, I would like to look at the June 2019 Physics Mid-Year Exam, Paper 1. I'm going to do all the questions separately, so I'll put the 10 multiple choice questions here. It says to you, consider the following diagram of a wave with a frequency of 12 Hertz. The distance AB can be described as. Now I want to say to you in multiple choice, sometimes they give you too much information, sometimes they give you misleading information. This frequency is completely irrelevant to the question. It's got nothing to do with the question. They are trying to vaguely trick you. So here it says to you, what is the distance AB? The distance AB is twice the amplitude. Remember, the amplitude is the maximum displacement of a particle from its position of rest. So from this equilibrium or rest position, particle A is at its maximum displacement. So AB is double the amplitude. So the answer is D, twice the amplitude. Okay, let's go to the next question. Ultrasound is used by doctors to study an unborn fetus. The principle of ultrasound scanning is based on resonance is when you have two waves that are in harmony and they create overtones and subtones. It is indeed B, reflection, because what happens is they reflect the sound waves, the ultrasound waves hit the fetus, and some of them are transmitted and some of them are reflected, and where they are reflected the tissue is denser, and that's how you can see what the fetus looks like. Refraction is the bending of light. There's a small amount of this, but it happens, but the receiver is not using the refracted rays. The receiver on the ultrasound scanner is using the reflected rays. And superposition is when two waves interfere and the crests get bigger or the crests get smaller. So this is not the case. What would a drummer do to make the sound of a drum produce a note of a higher pitch? Okay, if you hit the drum harder and you hit the drum less hard, all you are doing is changing the amplitude of the wave. Pitch depends on frequency, so you have to change the frequency. So a higher pitch is a higher frequency, so you need to have a shorter wavelength. So if the drum skin is loose, there is a long wavelength because the drum skin is a little bit bigger. If you tighten the drum skin, it cannot make a longer wave because the drum skin is tighter and it is shorter. So if you tighten the drum skin, you are increasing the frequency and therefore increasing the pitch when you hit the drum, because it can only vibrate with a certain wavelength. It says to you, 5 waves in a slinky require 1.5 seconds to move past a fixed point. The length of each wave is 0.2 meters. The period is. Okay, so period is not related to the wavelength. We need the period to be related to the frequency. So there are 5 waves in 1.5 seconds. So what is the period? The period is how long it takes a full wave to pass a point. So if there are 5 waves in 1.5 seconds, then one wave is going to be 1.5 divided by 5, which gives you 0.3 seconds. Then it says to you, if a wave has a frequency of 0.6 Hertz and a wavelength of 10 meters, what would be its speed? Here, remember, anytime you do multiple choice questions, you can also use your data sheet. So we have an F and we have a lambda. Okay, so V equals F lambda. So we should have here an answer of C, because 0.6 times 10, V equals F lambda, is going to give you 6. C. Now it says to you, a glass rod is charged positively by rubbing it with a silk cloth during the process. So if the glass rod is positive, it has lost electrons. So we need to only move the electrons. C and D are immediately out because they have moved the protons. You may not move the protons. Only electrons can be transferred. So when the glass rod becomes positive, it must have lost electrons. So the electrons have gone from the glass rod to the silk cloth. The answer is A. And if you have the memo, it's got a different answer, but this is the correct answer. Now remember what I said a moment ago, when you do multiple choice, you actually also have to do calculations, okay? So here, first of all, you have to realize series circuit, parallel circuit, two parallel circuits in series, parallel, series. So you need to know how to work out the effective resistance here. So it says to you, which of the following arrangements will result in a total resistance of 4 ohms if the resistors are all 4 ohms? So we can immediately rule out anything in series, because the formula for resistance in series is R total equals R1 plus R2 plus R3 dot dot dot. So this will be 4 plus 4 plus 4, which is 12. So this is out, okay? This is 1 over 4 plus 1 over 4 plus 1 over 4, and then you invert the answer. It's not going to work, because this is going to give you 1 over 4 plus 1 over 4 plus 1 over 4 gives you 3 over 4, which you have to invert to find the resistance. Remember, this is the tricky formula. So then you get 4 over 3, so you've got 1,3 ohms. So this is wrong, okay? So then here we have 1 over 4 plus 1 over 4, because these two are in parallel. So a quarter plus a quarter is a half, and this is also going to be a quarter plus a quarter is a half. But remember that I have to invert this a half. A quarter plus... I'm wondering if I should show you the formula here. Look here. Here's the formula for resistors in parallel. So we had 1 over 4 plus 1 over 4 gives you 2 over 4, which is 1 over the resistance. So 4 over 2 is 2. So this is going to be 2 ohms resistance, and this is going to be 2 ohms resistance, and 2 and 2 is 4. So the answer is C. This is going to give you a minimum of 8 ohms. 8 ohms plus 1 ohm, this is 9 ohms, 9,3 ohms. Then this is 1.8. All electromagnetic waves traveling in a vacuum have the same speed. This is C. You have to learn this. Remember that that's the thing about electromagnetic waves. They don't need a medium for propagation, and they all have the same speed, little c, from Einstein's E equals mc squared. So the answer is speed. Intensity is brightness, and the frequency and the wavelength, that depends on whether you have, for instance, infrared light, ultraviolet light, things like that. Now this one here, 1.9. Two identical metal spheres on insulated stands carry charges of x coulombs and -5 coulombs respectively. They are brought into contact with each other and then separated again. Each sphere now has a charge of 3 coulombs. The value of x is. So this is the law of conservation of charge, and whenever you see the law of conservation of charge, you know that you have to use this formula. Q equals Q1 plus Q2 over 2. So they are telling you in this question, let's look at the question again. They are telling you here, one charge was -5, but at the end of the day, everybody ended up with +3. So if we come back to the formula, the +3 is the answer to a -5 plus x over 2 equals something. So you have to substitute into this formula. So this was a 3 because that's what they came out of it with. So 3 times 2 by algebra is 6. 6 equals x plus -5. So it's x minus 5. So the answer must be 11, because by algebra we're going to go 6 plus 5 because it's -5 on the other side. So here the answer should be C. Now this one you just have to remember the unit in which electrical current is measured. Current is I. We measure current in amps. If you can't remember this, you're not going to get a mark for any of your electricity questions because you're not going to put a unit on the answer. You have to know the symbol and the unit for everything.